It is the first page. What I explained already. So one more time I will explain. I will explain from starting, don't worry. You should read all the subjects I have. In competitive exams, you should not take it light. First read the easy papers. First study easy subjects. And then go for the difficult subjects. Like controls, networks, digital, signals, like this. Easy subjects, maths, physics, aptitude. So like this, first easy subjects you study, then go for the core subjects. Core subjects, you first complete easy subjects in a minimum time. Now time also almost it is November. Gone. December means not even 1 week, one subject you will get. You should study. Okay, I'll start it already. Okay. Hello. Still not able to join. New page is created, na?
Sir, refresh చేసి జాయిన్ అవ్వమన్నాడు సార్.
రిఫ్రెష్ అంటే చేసి జాయిన్ కాండి. రిఫ్రెష్ చేసి జాయిన్ కాండి. రిఫ్రెష్ చేసి జాయిన్ కాండి. అదే 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 జాయిన్ కాండి. నవీన్
సార్ ఫస్ట్ లింక్ ఒకటే వస్తుంది సార్, మిగతా రెండేమో మీటింగ్ ఇన్ ప్రోగ్రెస్ అని వస్తుంది.
day 16 న్యూ అనేది కూడా అలానే వస్తుందా? రిఫ్రెష్
డే 16 న్యూ అని రెండు. అదే సార్, day 16 న్యూ రెండు ఉన్నాయి, దాంట్లో ఫస్ట్ ఒకటే వస్తుంది సార్.
దాంట్లో వస్తుందా day 16 న్యూలో? హలో,
వస్తుంది సార్.
ఓకే, జాయిన్
వస్తుంది సార్.
ఓకే ఓకే. day 16 న్యూ ఓపెన్ అవుతుంది. ఓపెన్ ద day 16 న్యూ. Right. I think many are joined already. So let's start. Right. See here. I selected first. The transfer function is k by s power 4 minus 1. That means you can write it as s square plus 1, s square minus 1. S power 4 minus 1 means a square minus b square, na? A plus b into a minus b, like that we can write. So s square plus 1, s square minus 1. Then find the roots. You'll get what happened, s equal to plus or minus j1. S square minus 1 means s equal to plus or minus 1. And here there exists the root locus branch. Here there exists the root locus branch. And breakpoint to find it, d by ds of 1 by s power 4 minus 1. It differentiate 0 minus 1, 4s cube. So if we differentiate s equal to 0, s equal to 0 is a valid breakpoint because 0 is on the root locus branch. It is a valid breakpoint. Just number of asymptotes you find. Number of asymptotes equal to p minus z. Number of asymptotes p minus z. So p is 4, z is 0. That means 4. Angle of asymptote theta equal to 180 by p minus z. 180 by 4. First angle 45. Multiply with odd number 40 into 1. 45 into 1, 45 into 3, 45 into 5, 45 into 7. 4 angles na 45, 135, 225, 315 you will get. Centroid becomes the 0. Centroid becomes the 0. Okay. So now just now only started. This is the first page. Okay, I'll discuss the homework problems later, no doubt. Okay. Right. Now, listen all of you, just now only started. This is the first page. Just I calculated a breakpoint, identify real axis root locus branch and angle of asymptotes and centroid I calculated. Okay, na? So next, then we will represent we'll draw the diagram because we calculated already breakpoint 0, angle of asymptote, centroid we calculated. So here angle of departure also you have to calculate because complex poles are there. We'll calculate angle of departure also. We'll calculate angle of departure. So first we'll calculate it angle of departure first. Come on, calculate all of you. Angle of departure we calculate all of you. Come on. Calculate angle of departure. Angle of departure, AD. Angle of departure. Come on, do it. Angle of departure. Calculate angle of departure. So where I have to calculate angle of G of S, H of S at S equal to what? Plus J1. Positive imaginary, na? We have to calculate at positive imaginary plus J1. So calculate that equal to what? Angle of K. Then denominator can be written as angle of S plus 1, angle of S minus 1, angle of S plus J1, angle of S minus J1, angle of S minus J1. So now come on, substitute J1 and find the angle of departure. Then what I am getting? Angle of K divided by J1. If you substitute, what I will get? Angle of 1 plus J1. S equal to J1 is substitute. So angle of what I will get? Minus 1. S equal to J1. So plus J1. Then here what? J1 plus J1. Next here what? J1 minus J1. J1 minus J1. J1 minus J1. So then angle of K becomes 0 degrees divided by Angle of 1 plus j1, tan inverse of imaginary part by real part. Tan inverse 1 by 1, 45 degrees. Or we can write tan inverse of plus tan inverse of imaginary part 1, real part 1, plus which region? Minus 1 plus j1 means second region. Minus 1 negative real. j1 means positive imaginary. Second region. What is the angle? 180 minus tan inverse. 180 minus tan inverse of imaginary part by real part. That means 180 minus tan inverse of imaginary part 1 by real part is 1. Next, angle of J2 means 90, J1 plus J1 means J2. Angle of J2 becomes the 90 degrees. Either J1 or J2, whatever it is, same na? Angle of J2. Any point on positive imaginary, 90. Here J1 cancelled. That means angle of 0 becomes the what? 0. Now solve this cancel. Then what you are getting, tell? So what you are getting? 180 plus 0 by 0 degrees by 180 plus 90 degrees. That means how much? Minus 270 degrees you are getting. So then find pi d. Pi d equal to 180 plus angle GH. 180 plus angle GH of S. So that means 180 minus 270. 180 minus 270. Minus 270. Minus 270. So that means minus 90 degrees. Angle of departure becomes minus or plus 90 degrees. Minus or plus 90 degrees. Angle of departure becomes minus or plus 90 degrees. Okay. So minus or plus 90 degrees angle of departure. Okay, na? Now draw the diagram. So we calculated everything. Now draw the diagram. Come on. Draw the diagram. J omega. This is plus J1. K equal to 0. Minus J1. K equal to 0. Plus 1. K equal to 0. Minus 1. K equal to 0. So now represent the root locus branches. Here there exists a root locus branch. Already we represented. There exists a root locus branch. Then break point. Here S equal to 0. Break point also 0. Break point is 0. Centroid also 0. Centroid also 0. Break point 0. Centroid 0. Yes or no? Centroid 0. Centroid equal to 0. Centroid also 0. So this is the what? Representation. Now with respect to centroid, you have to draw the angle of asymptotes. What are the angle of asymptotes? 45, 135, 225 and 315. We'll draw the angle of asymptotes. We'll draw the angle of asymptotes. So draw the angle of asymptotes. So one is 45. You can draw 225 also. Right. This is the angle of asymptotes for asymptotes with respect to centroid. With respect to centroid. So 1, 1, 0 along the 45 degrees where K equal to infinity. 1, 0 along 135 degrees where K equal to infinity. 10 along 225 degrees, where k equal to infinity. 10 along 315 degrees. 315 degrees, where k equal to infinity. So now 4 asymptotes. So 4 asymptotes. We got it 4 asymptotes. Okay. Okay, na? Now these are the 4 asymptotes. Now draw the root locus diagram. Angle of departure, we got it what? Minus 90. That means this is minus 90. This pole depart with the angle of minus 90. Minus 90 na, like this. This is minus 90. This pole depart with plus 90 like this. This pole depart with plus 90. This pole depart with minus 90. So now draw the root locus diagram. As k increases, what happen? This pole depart with the angle of minus 90. This pole depart with the angle of plus 90. This pole depart with the angle of, this is 180 degrees na, or towards the left. This pole moves toward the right. That means 0 degrees. All the 4 poles moving equal in opposite direction. All the 4 poles move in equal and in opposite direction. All are moving equal in opposite direction. All are moving in equal in opposite direction. Then all the 4 poles meet at the break point. All the 4 poles meet at the break point. Even this question asked, how many poles meet at the break point? So 4 poles meet at the break point. Here 4 poles meet at the break point. Be remember one statement. Whenever, remember this statement. Whenever break point equal to centroid, break point equal to centroid, and all the poles are symmetrical about the break point, and all the poles are having equal distance. All the poles are having equal distance from centroid. Equal distance from centroid. All the poles are having equal distance from centroid. Then all the poles meet at the breakpoint. It is valid for all the problems, sir. It is breakpoint equal to centroid anywhere is there. If the poles are having equal distance from the centroid, all the poles will meet at centroid, no doubt. Then all the poles meet at centroid. All the poles meet at centroid. That is the centroid, even that is the what? Break point. In this case, there is only one break point that will become centroid only. In this case, the system having only one break point. The system having only one break point. Now check it. Break point is what? 0. Centroid is 0. What is the distance from centroid to poles? Check it. Centroid to poles, you check 1 unit. 1 unit. 1 unit. 1 unit. That means all are having equal distance. Then all will meet. Only all are having equal distance. Then only all will meet at the what? Break point. So now how many poles meet at the break point total? 4 poles meet at the break point. Once 4 poles meet at the break point, it leaves from the real axis by maintaining angle of what? Plus or minus 180 by n. N is called 4 because 4 poles. That means it leaves the real axis with an angle of plus or minus 45 degrees. It leaves the real axis by maintaining angle of plus or minus 45 degrees. Here 4 poles are there. Then one pole leaves with an angle of 45 degrees like this. It enter into asymptote directly with 45 degrees. Then it will go on another pole minus 45 like this. Another pole minus 45. It will move along this minus 45, minus 45. This is plus 45. Here phase shift 45 to 45 is 90 degrees. So here also same phase shift should be there. All the poles should live by maintaining equal phase shift. I told in the last day also. So here phase shift is 90. So that means 45 plus 90, 135. That means another pole live with 135. 135. Again here also 90. 135 plus 90, 225. So another pole also live with 225. All the four poles live by maintaining the phase shift is 90 degrees between any two poles. By maintaining the phase shift between any two poles is 90 degrees. Directly enter into asymptote and occupies the zero. All the four poles directly enter into asymptotes and occupies the what? Zeros. All the four poles occupies the zeros. So occupies the zeros. So this pole also it occupies the zeros. All the four poles it occupies the zeros. So like this. So four poles it occupies the zeros. You remember this statement, whenever breakpoint equal to centroid and all the poles having equal distance from centroid, then all the poles meet at centroid or breakpoint. In this case, there will be only one breakpoint. And one more statement also I want to tell, it is also important. Whenever, listen, whenever breakpoint equal to centroid, breakpoint equal to centroid, that equal to real part of the complex pole, then the angle of departure no need to calculate. Directly we can write minus or plus 90. So write that statement, whenever breakpoint equal to centroid, that equal to real part of the complex pole, that equal to real part of a complex pole, that equal to real part of a complex pole, complex poles. So then that equal to real part of a complex poles, then the angle of departure is, then the angle of departure is, no need to calculate it, directly we can write. The angle of departure is pi d minus or plus 90. It is valid for all the problems. For example, what is the breakpoint in this case? Tell 0. What is the centroid? Tell 0. What is the real part of complex pole? Complex pole real part 0 na? 0 plus or minus j1 na? So 0. All are same. If all are same means blindly we can write it what angle of departure is. All are 0, 0 only. So breakpoint 0. Centroid 0, real part of complex pole 0, all are same. Whenever all are same, without any calculation, we can write angle of departure is minus or plus 90 degrees. Angle of departure is minus or plus 90 degrees. Be remember this statement also. Okay, na? Next. One more thing. The K value at the break point is, come on, you tell. K value at the break point. Come on, what is the K value at the break point? K value at break point is, come on, K value at break point. How much? K value at break point. Come on, K value. One, very good. K value at the break point is 1. Product of lengths we can use, na? We can use product of lengths here. See here, this is 1, this is 1, this is 1, this is 1. And what? K equal to what? 1 into 1 into 1 into 1. 1 into 1 into 1 into 1 into 1. Divided by what? No zero, so 1. That means K equal to 1 into 1 into 1 into 1. Denominator 1. So equal to 1. Even use a magnitude condition. S is 0, na? Same answer you will get. Even magnitude equal to 1 or use magnitude condition. Magnitude equal to 1. So what happened? Magnitude of K by S power 4 minus 1. equal to 1. But what is the break point here? S equal to 0. S0 substitute K equal to 1. So at the break point, K value equal to 1. Sometimes they are asking closed loop transfer function at the break point is closed loop transfer function at break point is closed loop transfer function at break point. Tell how to find. We know G of S, H of S na. What is G of S, H of S? Tell K by S power 4 minus 1. Now substitute K equal to 1. So assume unity feedback either given or not. If you ask closed loop transfer function, assume unity feedback and proceed. Because we cannot write if you don't assume H of S1, it is not possible to write closed loop transfer function. That's why assume H of S1. Then what happened? K is 1 na, K value at break point is 1. So 1 by S power 4 minus 1. Then add the numerator term in the denominator. Directly, what is the closed loop transfer function? Tell. So G by 1 plus G. Simple logic, what I told. Add the numerator term in the denominator. So plus 1. So what is the closed loop transfer function? Tell. 1 by S power 4. 1 by S power 4. Simply assume unity feedback. Then find closed loop transfer. Substitute K value. Substitute whatever the K value got at that point. Then find closed loop transfer function. That will become a closed loop transfer function at the break point. And one more thing, is it stable? Tell. Is the system stable or unstable? Anybody? Is the system stable or unstable? It is unstable for all the values of K, unstable. Because one pole always right. Even come to imaginary 4 poles unstable. Again 2 poles right. That's why the system always unstable. So the given system unstable for all the values of K. For all the values of K. For all the values of K. So system is unstable for all the values of K. Once it is unstable, we cannot find the what any more factor. We cannot find any more factor. No range of K value, no natures, kuch bhi nahi. Natures also cannot define. Okay, na? Like this you have to solve. Next problem. Next problem. This you do homework. You can do by yourself. Simple problem. Try. G of S, H of S equal to Ks by S square plus 4. So you solve this problem in your home. You do by yourself. Ks by S square plus 4. It is easy only. Similar type problem is solved in the root contour. Same thing. But you try it. Okay, na? Root contour topic will come. There I will discuss. So this statement you remember. This statement very important. As well as this statement also very important. This statement also very important. These two statements you remember. This statement also remember. Next, one more problem. Now come on, draw the root locus. Draw RLD for G of S, H of S equal to, come on, jaldi. This chapter closed. This is a big chapter. That is a problem. S plus 1 whole square into S plus 2. Come on, do it. Just find the breakpoints. You do in your home, na? Breakpoints you can find, na? Huh? Breakpoints. Come on. Breakpoints you find in your home. Generally, I don't think they'll ask like this big question for even breakpoints. Why? Because fourth order. Fourth order means differentiation, third order. Third order roots cannot find without calculator. I don't think they'll ask. They don't ask it. I don't think. Okay, but still you try. One breakpoint we can identify directly, -1. One of the breakpoint directly we can identify, that is -1. because repeated poles. So you find the break point here. Okay, na? You find the break point. So d by ds of 1 by, expand the denominator. If expand it, s power 4 plus 4s cube plus I think 5s square plus 2s I think. 2s equal to 0. U dash means 0 minus u into v dash 4s cube plus 12s square plus 10s plus 2 equal to 0. Plus 2 equal to 0. Equal to 0. Now find the roots for this. Find the breakpoints. Find the roots. S equal to, Bolum, you'll get the roots is minus 0.29, one breakpoint, minus 1, minus 1.71 you will get. These are the breakpoints. You try to solve. You find the roots for this, you will get this. In the exam, what you do, any question in case they ask like this question. If you ask the breakpoints, what you do, you go from option to question. You go from first you solve up to this. You write dk by ds. You write dk by ds. Up to this you write. You write up to this dk by ds you write. After writing dk by ds, for example, they ask the breakpoint for this. So one option A, for example, minus 1. You substitute minus 1, the summation should be 0. First given breakpoint should be whatever the option you are selecting, that should be on the root locus branch. That should be on the root locus branch. For example, here what are the root locus branches? Tell. So one pole at origin, 2 poles at minus 1, here k equal to 0, here s equal to 0, 1 pole at minus 2, here k equal to 0. Here there exists a root locus branch. Here root locus branch exists. Here also there exists a root locus branch because 2 poles na root locus branches exist. Now you observe the options. For example, first option minus 1. So minus 1 is there on root locus branch or not, you observe. In case not there, for example, first option is minus 3. First option minus 3. So minus 3 is the first option. Minus 3 not on root locus. That means answer A wrong. Second option, for example, B option minus 1. Minus 1 is on root locus branch. May be correct. If it is on root locus branch, it may be correct. Now substitute this minus 1 here. If it is 0, correct. Come on, substitute it. So if I substitute minus 1 minus of 4 into minus 1 whole cube means minus 1 only na. Minus 1 whole cube, s cube, s equal to minus 1 substitute. S equal to minus 1 is substitute. Minus 1 whole cube means what? Okay, whole cube plus 12 minus 1 whole square plus 10 minus 1 plus 2. If this summation is 0, then it is correct answer. So that means minus 4 plus 12 minus 10 plus 2. What is the summation? 0. That means it is a valid breakpoint. That means it is a valid breakpoint. Like this, you have to select. Even if substitute minus 0.29 also, it will become 0. Minus 1.7 also, it will become 0. Anywhere, if you are unable to solve the equation, go from option to question. First, identify real axis root locus branches. Then after that, the point should be on root locus branch. Then after that, substitute in the dk by ds. If it is 0, then it is a valid breakpoint. Then it is a valid breakpoint. Okay, na? Then it is a valid breakpoint. Okay? Like this, we can identify the valid breakpoint. If you have to go from option to question, there is no alternate. Okay? Next, number of asymptotes. Come on. Number of asymptotes. Number of asymptotes. Jaldi. Number of asymptotes. N equal to P minus Z. That equal to 4. Angle of asymptotes. Angle of asymptotes. Angle of asymptotes. Theta equal to what? 180 by 4. 180 by 4 means what? 45 degrees. And next problem onwards, I'll draw directly all these factors you have to calculate. Because for many problems we are solving na same steps na. There is no difference. 180 by 4, 45, 135, 225, 315. Because 45 into 1, 45 into 3, 45 into 5, 45 into 7. Next centroid. Sum of real part of poles -1, -1 and -2. Minus of 0 divided by P minus Z is 4. That means centroid is -1. Centroid is -1. Okay, na? So now draw the root locus. Find the intersection point with imaginary. That and all you do by yourself. It is not required. Just I'll draw the root locus diagram. Okay, na? So now draw the root locus diagram. I'll draw in the next page better. So one pole at origin, two poles at -1, k equal to 0. Here also s equal to 0, k equal to 0. One pole at -2, here k equal to 0. Next here there exists a root locus branch. Here also there exists a. Why I am solving this problem means to say that repeated poles is a breakpoint. So when remain now whatever the problems I am solving, that and all only to know more about breakpoints and angle of departures. Otherwise it is not required. So only breakpoints and angle of departure, because direct 2 marks bit they are asking on breakpoints and angle of departures. That's why I am discussing. So one of the breakpoint -1, another breakpoint is what? -0.29. Another breakpoint is what? Another breakpoint is -1.71. -1.71. Now draw the angle of asymptotes. You draw the angle of asymptotes. Come on. You draw the angle of asymptotes. Angle of asymptotes. Sorry. Angle of asymptotes. Right. Right. So that means 1 0 along 45 degrees, where k infinity, 1 0 along 135 degrees, where k equal to infinity, 1 0 along 225 degrees, where k equal to infinity, 1 0 along 315 degrees, where k equal to infinity. K equal to infinity. Now draw the root locus diagram. We draw the RLD. So what happened here? Two poles lies at -1. It won't leave the real axis because adjacently it is having root locus branch. Don't think that when two poles lies on the real axis, it should leave. If in case there is no adjacent root locus branches, for example, in this case, you take this side no root locus, this side no root locus, automatically it leaves the real axis. But here adjacently root locus branch is there. Whenever adjacently root locus branch is there, so directly whenever adjacently root locus branches is there, it moves on root locus branch. It won't leave the real axis. But because of two poles, it is just like breakaway point, moving away from the point. It is just like breakaway point. So don't think that break point means it should leave the real axis. It is may or may not leave the real axis. So breakaway, moving away from the point is called breakaway. So repeated poles are there means blindly we can say that is a break point. So one pole moving toward the right, from right side another pole is coming in the opposite direction. Both will collide here. Then it leaves with collide two poles na, leaves with plus or minus 90. Then one pole near to asymptote, parallel to asymptote, enter into asymptote. occupies the 0. Near parallel enter. Another pole also same. Near parallel enter. Occupies the zeros. Near parallel enter occupies the zeros. Next again 2 poles. This pole also moves toward the left. This pole moves in opposite direction. Both will collide. Then what happened? Near to asymptote, parallel to asymptote, and occupies the 0. This is also same. Near to asymptote, parallel to asymptote, and occupies the zeros. This pole also same. So this is the root locus diagram. You find range of K value for stability by using RH criteria. That and all do by yourself. Okay, na? That and all do by yourself. Okay. Next problem. So here why I am solving means you remember whenever poles are repeated, that will become a one of the breakpoint. Whenever poles, not only poles, even zeros also, whenever poles or zeros are repeated, then it will become the breakpoint. Repeated, then it becomes the breakpoint. Then it becomes the breakpoint. Then it becomes the breakpoint. So be remember. For example, see one more problem I'll state. Simple problem. For example, I'll take a problem. G of s, h of s equal to, come on, k into s plus 1 whole square divided by s into s plus 2. Come on, do it. Do it. Nothing is there. Here number of asymptotes are 0. Angle of asymptote not required. Centroid not required. So no complex poles, no angle of departure, no angle of arrival, no intersection point. Only one thing you have to find. That is what? Breakpoint. So breakpoint you have to find for all the problems. So for example, here tell one pole at origin, s equal to 0, k equal to 0. 2 zeros at where? -1, k equal to infinity. One pole at what? -2, k equal to 0. One pole at -2, k equal to 0. Here there exists a root locus branch. Here also there exists a root locus branch. Root locus branch. Now tell what happened here. So 2 poles, 2 zeros. Nothing is there to calculate, but only you have to find breakpoint. D by ds of s square plus 2s plus 1. S plus 1 whole square, expand it. Divided by s square plus 2s equal to 0. Find it. No doubt you will get the breakpoint equal to -1. No doubt about it. You will get breakpoint equal to -1. Why? Because as k increases, both the poles move in opposite direction. Then both the poles what happen? Meet at -1. What is the breakpoint definition? Whenever 2 or more poles meet or directly locate, that is called a breakpoint. So it is 100% breakpoint. It is just like break-in point. This is just like breakaway point. This is just like break-in point. Break-in point. Because 2 poles are enter into the point. It is just like break-in point. Don't think that break-in point means it should enter the real axis. It may or may not enter into real axis. Okay, na? So don't think that the pole should come away from real axis to enter into real axis. Okay, na? So this is called break-in point. So be remember the multiple poles, multiple zero locations act as a what? Break point. Multiple poles, multiple zero locations act as a break point. Okay, na? Next problem. Come on, jaldi. We have to solve homework problems also. Next. First, we'll discuss effect of addition of poles and zeros. After that, I'll discuss the these problems, homework problems. Okay? So, to discuss effect of addition of poles and zeros, first draw the root locus for these problems. GH of S equal to K by S. Come on. Draw the root locus for GH equal to K by S. Come on. Srinivas, draw the root locus, remain students. What is the doubt? Hello? Hello? Voice not audible. Check the connections. Okay, at the end we'll discuss, okay? Voice is not audible, we'll discuss at the end. Right. So now come on, only one pole at origin. Draw the root locus, tell. Number of asymptotes are what? 1. Angle of asymptote is theta. Theta equal to what? 180 by 1. That means what? 180 degrees. Angle of asymptote 1. Centroid not required. Breakpoint 1 with one pole breakpoint is not exist. Minimum 2 poles are required. Now draw the root locus diagram. Now draw the root locus diagram. Come on. So one pole at origin. S equal to 0. K equal to 0. Is there root locus branch here? Yes or no? It is a root locus branch. Now one asymptote at 180 degrees. At 180 degrees, there is a one asymptote where K equal to infinity. This is minus infinity. So as K increases, the pole moves toward the left, it occupies the 0. The pole go on, moves toward the left, occupies the 0. Then what happens? For all the values of K greater than 0, closed loop system is stable. For all the values of K greater than 0, closed loop system is stable. The system becomes stable. For all the values of K greater than 0, the closed loop system is stable. Right. Intersection point with imaginary, all that you do in your home. Next, draw K by S square. Come on, next problem. So one pole at origin K by S I taken, it is a stable. Which system? I am not talking about open loop stability. I am talking about closed loop stability. Closed loop system is stable. Now draw for K by S square, all of you. Now draw for K by S square. Tell me, what is the doubt? Srinivas? No doubt? Okay. At the end, we'll discuss. Right, come on. Right, K by S square. So number of asymptotes, how many? 2. Angle of asymptotes what? Theta equal to what? 180 by 2. 180 by 2 means what? 90. Multiply with odd number into 3. So 90 into 3 means 270 degrees. So breakpoint by default we can write 0 because 2 poles at origin repeated. Even dk by ds is solved. S equal to 0 will get. Breakpoint is 0. Centroid, there is no real part, 0. Now draw the root locus diagram. Come on. Draw the root locus diagram. There are 2 poles at origin. Centroid 0. Pole location 0. Breakpoint is 0. So this side no root locus, this side no root locus. So this side no root locus. Here also no root locus. No root locus. No root locus. Simply what happened? As K increases, the pole leaves the real axis. The poles leaves the real axis with an angle of plus or minus 90. So one asymptote along 90. That means along 90 degrees there is a 0 where K equal to infinity. Another asymptote along 270 there is a 0 where K equal to infinity. So what happened? One pole simply moves along the 90 degrees and occupies the zeros. Another pole moves along 270 degrees, occupies the 0, when k equal to what? Infinity. So what happened? The system tell, is it stable or unstable? For all the values of k greater than 0, the closed loop system is marginal stable here because the poles are moving on imaginary axis. For all the values of k greater than 0, the closed loop system is marginal stable. One pole, when I selected k by s, the closed loop system become stable. When I selected two poles, what happened? The closed loop system become marginal stable. So that means what do you understand here? The stability go on affecting. The stability, 3 poles you put it, it will become unstable because 3 poles means angle of asymptotes are what? 180 by 360 degrees. 60 degrees means right side. The system becomes the what? Unstable. So this system marginal stable. I want to make it stable. How can you make it stable? The above system is marginal stable, but I want to make it stable. How can you make it stable? Anybody? The above system is marginal stable. The system is marginal stable. To make it stable, it is required to add. It is required to add finite zeros. How many? 2 poles means 1 finite zero. So we require to add one finite zero in the left of the S-plane. To make it stable, it is required to add finite zero in the left half of S-plane. Left half S-plane. Left half S-plane. For example, you consider g of s, h of s equal to. Same thing, I will add a 0 in the numerator. S plus 1 by s square. Come on, draw the root locus diagram. Draw the root locus diagram. K into s plus 1 by s square. Srinivas. Right. Get the answer, come on. Number of asymptotes 1. Angle of asymptote 180 degrees. Centroid not required. You find the break point. You do in your home now, you can do now. Break point means simply what you have to do? D by ds of s plus 1 by s square equal to 0. Then what happened? 1 into s square minus s plus 1 into s square differentiation 2s equal to 0. Now solve this. You'll get the break point is, I think, minus 2 will get. S square minus 2s square minus 2s equal to 0. That means minus s square minus 2s equal to 0. Then what is the break point? Tell s equal to 0 comma minus 2. So there are 2 break points. One is 0, one is minus 2. Both are valid break points only. So break points is 0 comma minus 2. 0 comma minus 2. Draw the RLD, for example. You draw the RLD here. So here 2 poles at origin. S equal to 0. K equal to 0. It is one of the break point also. and 1 0 at -1, k equal to infinity. Here no root locus, here no root locus, but here there exists the what? Root locus branch. Here there exists the root locus branch. Number of asymptotes, how many got it? 1. What is the angle? 180 degrees. At 180 degrees, k equal to infinity. At minus infinity, there exists a what? At minus infinity, there exists a 0. And one break point. Here, this is root locus branch. Na? One of the break point is -2. This break point is -2. Two break points, na 0, -2. Both are on root locus. So both are valid. If I draw the diagram, as k increase, these two poles just leave the real axis. Just leave the real axis. It will enter at the -2, just like circle shape only. It will enter at -2. It enter at -2. Then one pole moves towards the what? -1. Another pole moves along the what? Minus infinity. This is the what? Root locus. So this is the diagram. So what you observed here? Here marginal stable. Here what happens? Stable. For all the values of k greater than 0, no doubt the closed loop system becomes stable. That means addition of 0 makes the system more stable. Addition of 0 makes the system more stable. Addition of pole makes the system less stable. Addition of pole makes the system less stable. Addition of pole makes the system less stable. Less stable. So pole means less stable. 0 means more stable. For example, I will add one more pole. For example, one more pole I will take. So g of s h of s equal to k by s cube. K by s cube. Now tell what happened. K by s cube means number of asymptotes 3. Angle of asymptotes bolo 60, 180 by 3 na. 180 by 3. 180 by 3. 180 by 3. 180 by p minus z na. P minus z is 3. So 60. Multiply with odd number. 60 into 3, 180. 60 into 5, 300 degrees. 60 degrees means right side, that's all gone. So break point 0 because 3 poles repeated. Centroid also 0. Centroid also 0. So now if you draw the diagram here, if in case draw the diagram, 3 poles at origin, if you draw the diagram, it is unstable system. 3 poles at origin. 3 poles at origin. One asymptote along 60 degrees. Along 60 there exists 1 0. Along 60 1 0, k equal to infinity. Along 180 1 0. Along 180 1 0. Along 180 1 0, where k equal to infinity minus infinity. Another asymptote 300. Another asymptote 300. Along 300 degrees, k equal to infinity. Now here k equal to 0. K equal to 0 here. 3 poles at origin. K equal to 0, S equal to 0, break point also 0. As k increases, one pole leave plus or minus 180 by n. N is 3 means what? 60 degrees. One pole move along the 60 degrees, occupies 0. Another pole moves along minus 60, occupies the 0. Another pole moves toward the left, it occupies the 0. That means what? All the poles occupies all the zeros. So for all the values of k system, what? Closed loop system, unstable. Why it is unstable? Two branches are moving toward the right side. That means what is the conclusion? Tell. What is the conclusion? If you go on add the poles, the system becomes the what? Less relative stable. Added pole means root locus branches go on move toward the right side. If you add 0, for example, here if you add 2 zeros, then the system becomes the what? The system becomes the what? Marginal stable. So whenever you want to make it stable, in case n poles at origin is there, required n minus 1 zeros in the left of S plane to make the system stable. If n poles light at origin, if n poles lies at origin, then required n minus 1 finite zeros, in the left of S plane, in the left half of S plane. So if n poles lies at origin, then required n minus 1 finite zeros in the left half of the S plane to avoid effect on system stability. To avoid effect on closed loop system stability. Closed loop system stability. For example, see here 2 poles. Means n minus 1 means at least 1 zero required. Automatically 1 more zero will come with asymptote. So means 2 poles, 2 zeros. Poles move towards the zero, na zeros will be left. Automatically system becomes the what? Stable. For example, if I want to make this system stable, 3 poles are there. That means I need to assume 2 zeros in the left hand side. 2 zeros left. Automatically 1 zero will get in the left with asymptote. Total 3 zeros left. So 3 poles automatically comes in the towards the left. All are going to be what? Stable. All are going to be stable. Okay. Next. So next, effect of addition of poles and zeros. Effect of addition of poles and zeros. Okay, next page will start better. So addition of poles, what is the conclusion? Addition of poles makes system less stable. Unstable or less stable. Okay, next page I'll write. Right. Effect of addition of poles and zeros. Effect of addition of open loop poles, GH poles, open loop transfer function means GH. Poles and zeros on closed loop system. GH poles and zeros on closed loop system. Okay, GH means closed loop system only, but which poles means GH poles and zeros. Right. First step, what happened? First point, what happened? First, poles and zeros should be added only in the left half S plane. The addition of poles and zeros only in the left half of S plane. The addition of poles and zeros only in the left half of S plane. Only in the left half of S plane. The addition of poles and zeros only in the left half of S plane. You should not add any pole in the right. You should not add any zero in the right. Add pole in the right, directly unstable. If you add zero, also going to be unstable because the pole moves towards the zero, na? So system become unstable. That's why compulsory you have to add only left half of the S plane. Next, first discuss addition of poles. First discuss addition of poles. Addition of poles. Right. 6 step slide. Okay, right. Come on. So addition of poles. Listen, addition of poles. First point is what? Root locus branches shift toward the right of S-plane. Root locus branches shift towards the right of S-plane. Towards the right half of S-plane. Root locus branches shift towards the right half of the S-plane. Right half of the S-plane. Step 2. Step 2. Bolo, step 2, bolo. The system becomes less relative stable. The system becomes less relative stable. First point, this is the second point. Third point, come on, third point. Third point. The range of K value persistent stability decreases. The range of K value for closed loop system stability decreases. Everything, stability means closed loop only. System means here closed loop system only. The range of K value for closed loop system stability decreases. Right side means decreases only. Now poles are moving right means range of K decreases. Fourth one. As the poles moves, what happen? As poles moves to right, what happen? What happens? System become more oscillatory. The system becomes more oscillatory. The system becomes more oscillatory. The system becomes more oscillatory. Next, fifth point. What is the meaning of addition of pole? Addition of pole means adding a low pass filter. 1/S is called integrator. Integrator is a low pass filter. Addition of pole is nothing but adding no pass filter. Addition of pole is nothing but adding low pass filter. Adding low pass filter. Low pass filter. If you add a low pass filter, what happens till bandwidth? Bandwidth is decreases. Adding low pass. Addition of pole is nothing but adding low pass filter. Hence bandwidth is decreases. Low pass filter decreases the bandwidth. High pass filter increases the bandwidth. Hence bandwidth decreases. Hence bandwidth is decreases. Bandwidth decreases. As bandwidth BW means bandwidth. As bandwidth decreases, noise is eliminated. Noise is eliminated. Noise is eliminated. Hence, signal to noise ratio, SNR. Malum na, signal to noise ratio. Noise eliminated means what? Signal to noise ratio is improved. Hence, signal to noise ratio is improved. SNR is improved. That is the advantage. Addition of poles main advantage is noise eliminated, system become more accurate. More accurate. More accurate. Means next what I can write? Addition of pole improves the steady state performance. Addition of pole improves the steady state performance. Improves the Steady state performance. That is more accurate. Steady state means accuracy. Steady state performance. In the bracket, you can write accuracy. Accuracy improves. But what is the drawback? Tell. As bandwidth decreases, bandwidth is inversely proportional to rise time. Na? So rise time always consider with respect to bandwidth only. So bandwidth is inversely proportional to the rise time. What happened? Tell. Bandwidth is decreasing means rise time increasing. So rise time increasing. That means rise time increases. Rise time increasing means system slow response. Na? Rise time increases. Not only that, root locus branches moving right means time constant increases. Na? Root locus branches moving right means time constant increases. Root locus branches moving right. Root locus branches moving right. Moving right means time constant increases. Means time constant increases. Hence what happened? Settling time also increases. That means rise time is increasing, settling time increasing. Settling time increases. So both are increases means what you can say? System response becomes slow. System response becomes slow. What I can write? 10th point, what I can write? Addition of pole makes the response slow. Addition of poles. Addition of poles makes the system response slow. Makes the system response slow. That is the problem. System response slow. What are the problems with addition of pole? System response is slow. Main problem is system may become unstable. Next problem is what? Slow response. Advantage is what? More accuracy. Advantage is accuracy because SNR is going to be improved. That's all. And last point, one more thing I can write. As the root locus branches moving right, what happened to the damping ratio? Decreases. Root locus branches moving right means zeta. Right side zeta negative. Aya. Root locus branches moving right. Moving right. Hence zeta decreases. Hence zeta decreases. Damping ratio right side is what? Negative. Zeta decreases means zeta decreases. As zeta decreases, so what happened? Percentage of MP increases. Percentage of MP increases. And system become more oscillatory. System becomes more oscillatory. Becomes more oscillatory. More oscillatory. And less relative stable. More oscillatory. And less relative stable. Less relative stable. That's all. These are effect of addition of poles. So these are very, very important for theory questions. This effect of addition of poles and zeros are very, very important. Even effect of addition of lead compensator, lag compensator, all if you want to write directly by yourself, just what we'll do, added pole or zero will identify, then we can write effects by yourself. You can write by yourself. I don't discuss also. You should write by yourself. I'll tell how to write it. But you should know this effect of addition of poles and zeros. Addition of pole, problem is less relative stable, range of K decrease, more oscillatory. This and all you have to remember. Advantage is more and more accurate. SNR is improved. That is the advantage. And another disadvantage, slow response. Next, addition of zeros. Everything opposite. Addition of zeros. First step, what I told? Root locus branches coming toward the what? Left side. It is coming left. So first step is root locus branches or shifting towards the left of S-plane. Root locus branches are shifting towards the left half of S-plane. Left half of S-plane. Second point. The system becomes more relative stable. The system becomes more relative stable. The system becomes more relative stable. Third one. The range of K value for system stability increases. The range of K value for system stability increases. The system becomes less oscillatory. The system becomes less oscillatory. Fifth one. Next tell. Addition of 0 is nothing but what? Adding high pass filter. Addition of 0 is nothing but adding high pass filter. Addition of 0 is nothing but high pass filter. Bandwidth increases. Addition of 0 is nothing but adding high pass filter. Hence bandwidth increases. Hence bandwidth is increases. As bandwidth increases, noise enter into the system. Noise enter into the system. Hence SNR decreases. Signal to noise ratio is decreases. Because noise increases, na, SNR decreases. Seventh point. See, next, as bandwidth increases, bandwidth inversely proportional to rise time, na? Rise time decreases. Rise time decreases. Next. As the root locus branches moving towards the left, moving towards left, time constant is decreases. Hence settling time decreases. Ninth. Addition of 0 improves the transient performance. Addition of 0 improves the transient performance. Improves the transient performance. Transient means speed. transient speed. Transient performance means it gives the quick response. Transient performance. Transient performance. Addition of 0 improves the transient performance. Transient means speed. 10th one. So what happened? Damping ratio. Come on. Zeta, what happened? As the root locus branches moving left, damping ratio zeta is increases. As zeta increases, percentage of MP is decreases. The system becomes less oscillator, more relative stable and less oscillator. That's all. These are the effect of addition of poles and zeros. Okay. Take the break. After the break, I'll solve the homework problems. That 6 homework problems will complete. And there is a conclusion that I'll discuss. Actually, that problems, they don't ask for 2 marks. But there is a theory conclusion. That theory conclusions, they may ask it. That's why I want to discuss that. Otherwise, we can skip it. Okay. I'll discuss it. Okay. Don't worry. Take the break. Take the break. Okay. 10 minutes break you take. Right. Right. Write it. Next. Homework problems will solve. First problem. What is that? G of s, h of s equal to k by s into s plus 4 into s square plus 2s plus 2. Come on, solve it. Come on, solve it. Solve it. So, number of asymptotes. Breakpoint, I hope you solved it. What is the breakpoint? I told you solve the breakpoint and angle of departures. -3. I'll take class up to 9:15 or 9:20. Okay. Okay, na? We'll see. We'll complete this homework problems first. So here, I hope you solved it. All of you breakpoint is solved by yourself. -3.09 is the breakpoint. Breakpoint is -3.09. Remain is invalid. This is the only valid breakpoint. This is only valid breakpoint. Now, where are the poles tell here? One pole at origin, one pole at -4, and complex poles are -1 plus or minus J1. -1 plus or minus J1. So now here there exists a root locus branch. So now tell centroid you find. First number of asymptotes are P minus Z. That equal to 4 minus 0. 4. Angle of asymptotes theta. 180 by P minus Z is 4. 180 by P minus Z is 4. 180 by 4. 180 by 4 means what I will get? 45 into 3, 135 into 5, 225 and 315. So these are angle of asymptotes. Centroid, sum of real part of pole -4 and real part of another pole -1, real part of another complex pole -1. There is no zeros, divided by P minus Z. P minus Z is what? 4. -6 by 4, -3 by 2 means centroid -1.5. Centroid is -1.5. Breakpoint is -3.09. I hope you find angle of departure. Angle of departure, I think, -63.43, I think. Minus or plus, you solve it. 63.43 degrees angle. Same steps, angle of departure already we solved. Angle of departure is minus or plus 63.43. Solved. Already I told how to solve. You cannot solve it. You have to go from option to question. Otherwise, you have to use calculator. They don't ask it. No need to worry. They don't ask. I told this problem, there is a one concept to explain only. They don't ask this question directly for 2 marks. No need to worry. So now draw the diagram. You draw the root locus diagram. Draw the root locus diagram. Draw the RLD. Not required. Roughly draw it. One pole at origin, k equal to 0. One pole at -4, k equal to 0. Here there exists a root locus branch. Here there exists a root locus branch. Root locus branch. Then centroid. Centroid is -1.5. Centroid. First complex poles are -1 plus or minus J1. -1 plus J1 minus J1. Centroid -1.5. Angle of asymptotes. One is 45 degrees. Along 4510, where k equal to infinity. 135 degrees. Where k equal to infinity. 225 degrees. 315. -315 No break point. What is the break point? -3.09. Angle of departure -63. Here +63. Here main conclusion is, see, listen here. At the break point, you got left of the centroid. This is the centroid. Left of the centroid. Automatically real poles moves toward the left. Why? Because break point is left of the centroid. As k increases, the real pole leaves at break point only. So as k increases, both the poles move in opposite direction, then meet at the break point. Then leaves. Where it will go? As it got break point left of the centroid, real poles moves toward the left hand side only, like this. Towards the left hand side only. It moves toward the left hand side, near parallel, and occupies the zeros. This is also same. Towards the left hand side only. It moves toward the left, near parallel, enter, occupies the zeros. Once the real poles are moving toward the left, there is no alternate to the complex poles. It has to move to the right only. No alternate. Compulsory it should move toward the right. First you think about the real poles. As the real poles moves toward the left, because break point is the left, the complex poles should move toward the right. So it depart with -63. It cross the asymptote, because intersection point with imaginary find it. It will be below this asymptote. It will cross the asymptotes and it will move near to asymptote, parallel to asymptote, enter into asymptote, occupies the zero. Here also same. So near, parallel, enter, occupies the zeros. What is the main concept here? Why I am discussing this big problems? This question they used to ask minimum 15 to 20 marks in the IES actually. IES I used to solve these questions on the graph sheet actually. IES conventional, not for objective. So what is the main concept is here? Be remember, whenever magnitude of the break point. What is the magnitude of break point? 3.09. Greater than magnitude of the centroid. Greater than magnitude of the centroid. Break point greater than centroid. Whenever magnitude of the break point greater than magnitude of the centroid, then the angle of departure is angle of departure is phi d is less than minus or plus 90 degrees. Whenever break point is greater than centroid, the angle of departure is less than minus or plus 90 degrees. At this pole less than minus 90. At this pole it become less than minus 90. At this pole it will become less than plus 90. At this pole it become less than plus 90. Be remember this. Whenever magnitude of the break point greater than magnitude of the, it is valid for all the problems, but complex poles should be there. Whenever root locus diagram having a complex conjugate poles and the magnitude of the break point greater than centroid, I'll write that statement also. Whenever root locus diagram RLD is having complex conjugate poles, complex conjugate poles, and magnitude of the break point is greater than magnitude of the centroid, then the angle of departure at complex poles is pi d is less than minus or plus 90 degrees. Less than minus or plus 90 degrees. Whenever RLD is having a complex conjugate poles and magnitude of the break point greater than magnitude of the centroid, then the angle of departure at complex poles is less than minus or plus 90 degrees. Next question is what? GH of S equal to K by S into S plus 1 into S square plus 2S plus 2. What is the break point here? Tell. Minus 0.39 remain or invalid. The number of asymptotes are same. Everything same. If I draw the diagram here, you find all the factors, number of asymptotes, angle of asymptotes, you find, you do it in your own. One pole at origin, K equal to 0. One pole is at minus 1. Same at minus 1 only. Complex poles are having. Plus J1. Minus J1. K equal to 0. K equal to 0. K equal to 0. Here exists the root locus branch. Break point is minus 3.09. Here break point. Minus 0.39. Centroid you find minus 1 for this positive imaginary complex and minus 1 for negative imaginary complex and minus 1 for real. No 0 divided by 4 means minus 0.75. breakpoint centroid is minus 0.75. So centroid minus 0.75. Centroid minus 0.75. Here, what is greater here? Which is greater? Magnitude of the breakpoint is less than magnitude of the centroid here. If I draw the angle of asymptotes, one asymptote is 45 degrees. Along 45, 10. One asymptote 135 degrees. Along 135 degrees, 10. One asymptote 225 degrees. One asymptote 315 degrees. K equal to infinity. Now, whenever angle of departure are you find here, angle of departure, you will get plus minus or plus 135 degrees you will get. Angle of departure either is solved or not, you will get minus or plus 135 degrees. What is the conclusion? Whenever root locus diagram having complex conjugate poles, whenever root locus diagram having complex conjugate poles and the magnitude of the breakpoint less than magnitude of the centroid, then the angle of departure at complex poles is greater than minus or plus 90 degrees. That is pi d is greater than minus or plus 90 degrees. This is the statement you be remember. The angle of departure is greater than minus or plus 90 degrees. Greater than minus or plus 90 degrees. So be remember this. Okay. So next, third question. This is second. Third bit. Third question. What is the third question? Tell g of s, h of s equal to. Third, fourth, fifth, very, very important. So s into s plus 2 into s square plus 2s plus 2. This case problem already I solved also. We solved this case problem. So what is this case means? Here breakpoint, you find it, you will get minus 1. Centroid also will get minus 1 only. So if I represent poles and zeros here, one pole at origin, k equal to 0. One pole at minus 2, k equal to 0. Minus 1. Plus j1, k equal to 0. Minus j1, k equal to 0. Now draw the root locus diagram. What happened here? Here there exists a root locus branch. Here there exists a root locus branch. Centroid is -1. Breakpoint to -1. So number of asymptotes 4. Same thing. One asymptote along the 45 degrees, where k infinity. This is j omega axis. Another asymptote 135 degrees. K equal to infinity. Another asymptote 225 degrees. K infinity. Another asymptote 315 degrees. K infinity. Just 4 asymptotes. Okay. So now, what did this case tell? I already told here breakpoint equal to centroid. What is the breakpoint? -1. Centroid what? -1. That is nothing but real part of the complex pole. That equal to real part of a complex pole. CP means complex pole. Real part of a complex pole. Once it is satisfied, what I told? The angle of departure is equal to minus or plus 90 degrees. I already told. The angle of departure equal to minus or plus 90 degrees. Another case also I told. Whenever breakpoint equal to centroid, that equal to real part of complex pole, the angle of departure is minus or plus 90 degrees. Minus or plus 90 degrees. And one more thing. Listen. Here, one more thing what? Whenever breakpoint equal to centroid and all the poles are having equal distance. All the poles are having equal distance from centroid. Then all the poles meet at the breakpoint. Meet at centroid or breakpoint. In this case, the number of breakpoints is only one breakpoint. This is also I told. What is the diagram tell here? As k increase, this depart with minus 90. This depart with plus 90. This is departing with plus 90. This is departing with minus 90. This is moving toward the right. This is moving toward the left. All the 4 poles meet at the point because all are equal distance. Check it. 1 unit, 1 unit, 1 unit, 1 unit. All are having equal distance. All will meet at the breakpoint. How many poles? Already I solved k by s power 4 minus 1. Today first problem. Same case. 4 poles meet at -1. Then once meet, it leave with an angle of plus or minus 40. One is moves with 45 degrees like this. Another pole leave with what? Minus 45 degrees. Because 4 poles na. Plus or minus 180 by n. N is 4. Leave with what? Plus or minus 45 degrees. One pole plus 45 go on, moves it and occupies the zeros. Another pole go on, moves and occupies the what? Zeros. So another 2 poles here 90, add 90 along 135 degrees it will go and occupies the what? Zeros. Occupies the zeros. Next, another 225 degrees moves and occupies the zeros. All the 4 poles occupies the zero. This is the root locus diagram. Here, what is the case? Breakpoint equal to centroid, that equal to real part of the complex pole. Be remember, the angle of departure is minus or plus 90 degrees. Minus or plus 90 degrees. ठीक है ना? Next, fourth problem. Fourth problem. G of S, H of S equal to K by S into S plus 2 into, I think, S square plus 2S plus 1.25. 1.25. So here you find the break points. You will get here 3 break points. 3 break points you will get. Either is solved or not. Minus 0.39, minus 1, minus 1.61. Angle of departure is minus or plus 90 degrees only. Centroid equal to minus 1 only. So if I represent here, listen all of you. So what happened? One pole here. One pole at minus 2. Here K equal to 0. 0, K equal to 0. Complex poles minus 1. Plus or minus J 0.5 only. Plus J 0.5 minus J 0.5. K equal to 0. K equal to 0. Here there exists a root locus branch. There exists a root locus branch. Now centroid also minus 1 only. One of the break point also minus 1 only. If you draw the asymptotes, one asymptote along 45 degrees, where K infinity. Another asymptote 135 degrees, where K infinity. 225 degrees, K infinity. 315 degrees, K infinity. So now draw the angle up. What happened? One break point minus 1. Another break point is minus 0.39. Another break point is minus 1.61. 3 break points. Angle of departure is minus 90. Here plus 90. Why? Because break point equal to centroid. Now one of the break point equal to centroid. Then angle of departure becomes minus or plus 90. What is this case tell? Whenever break point equal to centroid, angle of departure minus or plus 90. Why? Because here also break point equal to centroid, that equal to real part of complex pole. Real part of A. What is the break point? Minus 1. Centroid minus 1. What is the real part of complex pole? Minus 1. Real part of a complex pole. So satisfied this. Then angle of departure becomes minus or plus 90 only. Angle of departure becomes minus or plus 90. And one more case here. Whenever break point equal to centroid, whenever break point equal to centroid and complex poles are close to centroid. Are close to centroid. Complex poles are close to centroid compared to real poles. Compared to real poles. Real poles. Then the number of breakpoints on real axis increases. Breakpoints on real axis increases. On real axis is increases. The number of breakpoints on real axis is increases. Whenever breakpoint equal to centroid and complex poles are close to centroid, compared to, what is the distance tell here? 0.5. What is the distance here? 1 unit. What is the distance? 1 unit. What is the distance? 0.5. So that means what happened? The number of breakpoints, how many breakpoints you got here? 3 breakpoints you will get. We got 3 breakpoints. So what happened in this case means, as K increases, this complex poles 0.5 units only, 0.5. This is 1 unit. This complex poles first enter into real axis. 2 poles enter into real axis. So 2 poles enter into real axis. Then what happened? Once enter, it moves along the real axis. 1 pole moves to the right, but right side another pole is coming. Then again collide here. Again leaves here. Then near to asymptote, parallel to asymptote. Near to asymptote, parallel to asymptote, like this. This pole also same, near to asymptote, parallel to asymptote. Near to asymptote, parallel to asymptote. And here these 2 poles move opposite direction. Opposite direction. And collide. Leaves the real axis. Near to asymptote, parallel to asymptote. That's all. So be remember, whenever breakpoint equal to centroid and complex poles are very close to the real centroid, close to the centroid, distance you check it, centroid to pole distance you check, 0.5 units, compared to real pole, 1 unit, centroid to real pole, 1 unit. Complex poles are close means that complex poles enter into real axis, then the number of breakpoints on the real axis is increases. You cannot be remember this case also. Next, fifth problem. Fifth problem. G of S, H of S equal to K by S into S plus 2 into S square plus 2S plus 10. S square plus 2S plus 10. Come on, do it. Here breakpoint is, here also 3 breakpoints you will get. 3 breakpoints you will get here. What are that means? -1 comma -1 plus or minus J2. All are valid here. -1. Why? Because why it is valid means centroid is -1 only. Angle of departure minus or plus 90 only. Why? Because if I represent here, so here 1 pole at origin, K equal to 0, 1 pole at -2, K equal to 0, -1 plus or minus j. What is the pole location? -1 plus or minus j3, I think. Plus j3 minus j3. Then here there exists a root locus branch. Centroid -1. One of the breakpoint is -1. Angle of asymptotes, one is 45 degrees. One is 135 degrees. Two 25 degrees. Three 15 degrees. Three 15 degrees. Here also breakpoint equal to centroid. Breakpoint equal to centroid, that equal to RP means real part of complex poles. If it is satisfied means angle of departure is minus or plus 90 degrees. Angle of departure is minus or plus 90 degrees. Next one. Here K0. What is this case means? Whenever breakpoint equal to centroid, breakpoint equal to centroid and complex poles are away from centroid. Whenever breakpoint equal to centroid and complex poles are away from centroid, then away from centroid compared to real poles. Come on, check the distance. Complex pole 3 units, real pole 1 unit. Real poles are close. So compared to real poles, then complex breakpoints occurs. Complex breakpoints exist, we remember. Here also we got 3 breakpoints. One real breakpoint, one simply breakpoint, another one pair of complex breakpoint. One pair of complex breakpoint. So what happened here? One breakpoint -1 plus or minus J2, here complex breakpoint. -1 plus J2. Another one here, complex breakpoint. -1 minus J2. What happened here? As K increases, these real poles first both will move in opposite directions. Both will collide. Once it collides, it leaves with plus or minus 90 degrees. One is with plus 90. This will come with minus 90. Then again collide here. Then what happened? Near to asymptote, parallel to asymptote, like this. This is also near to asymptote, parallel to asymptote. This pole also move along this. Again, this will come with plus 90. Again collide here. Leave this complex axis. Near to asymptote, parallel to asymptote. Near to asymptote, parallel to asymptote. So like this, we got the word 3 break. Complex breakpoints only will get this case here. So when the complex breakpoint valid tell, I told it already. Complex breakpoint is valid only. Complex breakpoint is valid only when RP means real part of the complex breakpoint equal to real part of complex poles. Real part of complex poles. So bolo, what is the real part of complex breakpoint? -1. What is the real part of complex pole? -1. So that means it is valid. Otherwise, it is not valid. Otherwise, it is. What is the real part of complex breakpoint? What is the -1 plus or minus J2 is a complex breakpoint. CBP. Real part of complex pole -1 plus or minus J3. Both are same, na? Both are same. That means complex breakpoint is valid. Otherwise, it is not valid. Otherwise, it is not valid. This is complex pole. -1, -1. Both are same. Then it is complex breakpoint is valid. Okay, na? So this is the 5th question. Next, 6th question. 6th question solve. Come on. Do it. G of S, H of S equal to K by S into S square plus 6S plus 10. Come on, solve it. S into S square plus 6S plus 10. You solve it. Come on. Before this, 1 minute. Before this, I'll make the conclusion. How to identify the last 3 cases. Once in IES, object bit asked on that, 1 mark bit asked. They represented just pole locations. They asked match with number of breakpoints. They didn't ask location. Match with number of breakpoints. So how to identify means, first always find the centroid. First always find the centroid. If the centroid equal to real part of a complex pole. Centroid equal to real part of a complex pole in case complex poles. Centroid equal to real part of a complex poles. Once it is satisfied, then automatically just observe. Then you observe just. Centroid finding very easy, na? For example, if represented like this, -2, -1 plus or minus J1, like this represented, for example. What is the centroid? So -2 centroid equal to sum of real part of pole. -2, -1 for this pole, -1 this pole. No 0 divided by 4 means -1. Means -1 real part of complex pole also -1. So then immediately you have to identify the distance. What is the distance? 1 unit, 1 unit, 1 unit. All are equal. That means 1 breakpoint. So first check the centroid. That centroid should be equal to real part of the complex pole. -1, -1. Both are same. Then all the poles having equal distance. All the poles. All the poles are having equal distance. Equal distance from centroid. If all the poles are having equal distance from centroid, then there will be 1 breakpoint. Complex poles are close to centroid. Close to centroid, sigma. Compared to real poles. Then 3 breakpoints. But all are real only. Complex poles are away from centroid. Compared to real poles. Then 3 breakpoints. One breakpoint, one pair of complex breakpoints. So be remember this. Whenever they given some poles or they asked a question on the breakpoint, just to represent the poles, then find centroid. That centroid equal to real part of a complex pole. Then observe these 3. Equal, all are equal distance, 1 breakpoint. Complex pole scores 3 breakpoints on the real axis. 3 breakpoints on real axis only. On real axis. On real axis. So here away means you'll get 3 breakpoints. One is real. The second one is 1 pair of complex breakpoints you'll get. Okay, na? Next problem. Be remember this. Next problem. Come on, solve this problem. K by S into S square plus 6S plus 10. Come on, Guruji. Pair means 2. 2 pairs means 4 poles. 1 pair. Pair means 2 poles. First find the breakpoints. Here -1 is not a -1, you don't get it. You solve it. Breakpoints here -1.18 -2.81 you will get. You find centroid. Angle of departure is either solved or not. I think 72 or 82, -72 degree, minus or plus, I think 72 degrees you will get. And centroid is, come on, solve it. One pole at origin, K equal to 0. 2 complex poles. -3 plus or minus J1 you will get. Here root locus branches exist. You find the centroid. Sum of real part of pole -3 -3. For this pole -3, this pole -3. There is no more zeros, no more 4. क्या हो गया? Screen not responding. ఇది స్ట్రక్ అయింది ఇది. రైట్. One minute. Pen is not writing. ఏమైంది? What happened? What happened to this man? It is not. స్ట్రక్ కాకుండా స్ట్రక్ అయింది. వెంకటరెడ్డి ఏంది స్ట్రక్ అయింది? పెన్ను రాయట్లేదు. పెన్ను రాయట్లేదు. ఏది అసలు ఆపరేషన్ ఏది కావట్లేదు. స్ట్రక్ అయినట్టుంది. అంటే అక్కడ ప్రాబ్లమా ఇక్కడనా? అయిపోలేదు ఇంకా. ప్రాబ్లం మధ్యలో ఆఫ్ చేసి ఆన్ చేసి ఉన్న రియాక్షన్ వస్తుంది చూద్దాం. ఎందుకు ఇట్లా వస్తే కష్టం కదా. వస్తుందిలే. ఆఫ్ చేసి ఆన్ చేసి. ఓకే రైట్. ఓ రైట్. ఓ రైట్. ఓకే. So listen, -3, -3, -3 for this, -3 for this, minus no zeros divided by P minus Z is 3. That means centroid is -2. The centroid equal to -2. Centroid is -2. So then what happened here? Represent the centroid. Centroid is -2. -2 is the centroid. Then draw the angle of asymptote. One is 60 degrees. Number of asymptotes 3. Number of asymptotes 3. Angle of asymptote is 60. 180 by 3 na. So 180 by P minus Z. P minus Z is 3. So 180 by 3 means 60. 180 multiply under 300. So one asymptote is 60. Along 60 degrees, there exists one asymptote. Along 60, one asymptote. Along 180, one asymptote. Along 300, one asymptote, like this. Actually, it looks like there is no break point at all. It looks like there is no break point at all here. There is no break point at all because no two poles adjacent, no two zeros adjacent. But here we are having two break points. Why? Because these complex poles are close to the centroid. These complex poles are close to the centroid. The distance you find, it will be very less. I think root 2 you will get. This is 1, this is 1, this is root 2, but the distance is 2. So complex poles close. Whenever complex poles are close to centroid, complex poles are going to be enter into the real axis. So what happened? One break point is here. One break point is here, minus 2.81. Another break point is minus 1.18. This will depart with the angle of minus 72. This will depart with the angle of plus 72. Plus 72. Then what happened? As K increases, these two poles enter at the break point like this. These two poles enter at the break point. These two poles enter at the break point. Then one pole moves towards the left. It occupies the 0. Whenever complex poles are close to the centroid, just check the distance compared to real pole. Then complex poles are enter into the real axis. Then this pole will come in opposite direction. Again collide. Again near to asymptote, parallel to asymptote. Like this. So like this. So what is the conclusion? Whenever complex poles are close to centroid, by comparing real poles, then complex poles enter into real axis. Complex poles enter into real axis. Real axis. Then the break points are increases. In this case, number of break points on the real axis increases. In this case, number of break points on real axis increases. So it looks like there is no break point, but we got it to break. They don't ask like these questions for 2 marks. But this question they ask the number of the break points are. So whenever they ask the break points are, simply find dk by ds. You just find dk by ds. If that point lies on root locus branch, valid. Otherwise it is invalid. Just to find dk by ds. So if that point lies on root locus, then valid. Otherwise it is not valid. We cannot find dk by ds. If that point lies on root locus, then it is valid. That's all. Next, transportation delay systems is there another. I think it take another 1.5 hours. I think 1.5 hours to 2 hours it takes. Next topic, it will take more than half an hour. So better I'll discuss tomorrow. Today big problems we solved. And this pen also not working properly. The problem is there. We'll close it today. If you have any doubt, you can ask. Abdul.
సార్
Tell.
ఇది ఇప్పుడు ఈ ప్రాబ్లం ఉంది కదా సార్, ఇప్పుడు అన్ని కేసులు మనకి కాంప్లెక్స్ పోల్ ఇంకా సెంట్రాయిడ్ కి క్లోజ్ ఉండనక్కర్లేదా సార్? అంటే ఎప్పుడు ఉండాలా?
You
అంటే
check
కండిషన్.
it, that's all. Complex poles are not essential in all the problems, na? And complex poles is there, real poles is there, you check it, that's all.
ఓకే.
I know why unnecessary, not at all required for objective type. If you ask the break point, simply find dk by ds. If it is on root locus branch, then select the answer, that's all. Okay?
ఓకే.
Anywhere in case they ask the question, the root locus diagram is, then observe the 4 options.
ఓకే.
4 options, what is the difference? Generally in 4 options, 4 different breakpoint locations they'll give.
బ్రేక్ పాయింట్ లొకేషన్స్.
Then you just find the breakpoints and select the answer, that's all.
ఓకే. అంటే ఈక్వల్ టు 0 ఉంటే వచ్చేస్తే చాలు కదా సార్?
That's all. Okay.
ఓకే. థ్యాంక్ యూ.
Next, Jivika.
Hello.
Tell.
Yes, sir. How the addition of pole will increase the steady state response?
Pole
how
means
the-
what? Low
Pole
pass filter, na?
Yes, sir.
Noise eliminated,
Yes, sir.
Noise eliminated means accuracy increase or not?
Okay, then the signal accuracy increases.
That's all. Output in the output accuracy increase.
Okay, sir. So then, and how the addition of 0 increase the transient response?
Speed, race time decrease, bandwidth increase, na?
Okay. On the basis of the speed.
Yes.
Okay.
Next, Mohammed.
Yes, sir. Sir,
Tell.
in case when breakpoint equals to centroid and all poles are equal distance from the centroid, that case please open question number 3, sir. That is.
Tell.
Yes. Sir, can we say that the pole, this imaginary pole at -1 and plus j1 is coming to the breakpoint and it is going at an angle 45?
Yes.
Or I mean to say which pole is coming. I
That
want
we
the
cannot
direction,
identify.
sir.
Which pole moves which direction, that we cannot
that's-
identify at all. Once comes to -1, we cannot identify because all will be at the same point.
Okay. If from breakpoint we can't determine the
We
direction.
cannot identify.
Sir, and one more thing, addition of pole and addition of zeros regarding that topic. By adding LPF, the bandwidth decreases, and by adding HPF, bandwidth increases.
Yes.
Sir, actually, I don't know that point. Can you please tell how by adding LPF bandwidth decreases?
Border plot studied. N poles gives the slope of what? -20 n, it will come. N poles gives the slope of -20 n. One pole means what is the slope? Tell.
120, -20.
20. This is -20. This is the bandwidth.
Okay.
2 poles means -40. -40 means like this. What is the bandwidth? Decreased or increased?
Decreased, sir.
That's all.
I mean, low pass filter means, sir, relate the topic to this, sir. I understood this and understood that separately. Just relate.
Low pass means low frequency allowed. That's all.
Okay, sir.
It allows the low frequency signal, attenuates high frequency signal.
Okay, sir. Thank you.
Low pass filter is RC circuit, simple RC circuit.
Okay, sir. Okay, I understood, sir. Now, what about then adding zeros?
Zeros also for +20 n.
Plus
+20 n means what happened? +20 n zeros means automatically slope increases, bandwidth increases. 10 means what is the slope?
10 means 20.
And 2 zeros means
40.
what happened?
Decreased slope.
Increases, na?
Decrease, na, sir, slope. Slope.
Actually, how it will decrease?
Okay, sir.
For example, listen.
Tell, sir. Listen.
One system having 3 poles. This pen is not working properly. One system is 3 poles. 3 poles means what is the slope?
minus 60. 60.
I will add 1 0, minus 60. I'll draw the diagram. This is minus 60.
Okay, sir.
I will add 1 0. What happened? Plus 20 should be
Plus
added.
20. Plus 20.
That means minus 40.
Okay, sir.
How is minus 40? This is minus 40.
Okay.
What happened bandwidth?
Little bit increased.
That's all.
Okay, sir. Okay, sir. Understood now. Thank you, sir.
Okay. Next. Sumant.
Hello, sir.
Tell.
Sir, first example, page number 11F.
Tell.
In this, while it is converging to asymptote, sir.
It may cross asymptote. That depends on this intersection point.
It may cross or it may not cross, sir.
It may cross, it may not cross. That depends on intersection point with imaginary.
Okay, sir, that's it.
Okay. Next, Karthik.
Sir, page number 2F.
Page number 2F. Tell.
Yes, sir. Sorry, in 5D, if we directly substitute 180 degree plus angle of k by angle of s power 4 minus 1.
How can you
G
substitute
of f
directly s power 4
angle of
minus
g
1?
of
How
x
can you find angle of s power 4 minus 1?
Can't we substitute directly?
No.
S is
No,
equal
no,
to
it is not
G1
possible.
in.
You should go by expanded only.
Okay, sir.
Next, accounts.
Hello.
Tell.
So I'm having problem in volume 2,
Which
steady
question?
state. So page number 16, question 32.
Page number 16.
Yes, sir.
Question number
32.
32. Na.
Yes, sir, 32.
Question 32 not there in page number 16. Volume 2 or volume 1?
Volume 2, sir, 2.
2. Blue
Yes.
color.
Yes, sir.
Question, you read it.
So there is a control system with certain excitation is governed by following mathematical equation. And one equation is given, d square x by dt square plus half dx by dt plus x by 18 is equal to 10 plus 5 e to the power. Some exponential term is given. And we have to find the natural time constant of the response of the system.
Natural time constant means simply what you have to find.
So omega and
Omega.
sorry.
Natural time constant means tau you have to find.
Yes, sir, tau.
Tau you have to find. That means what you have to do? Left hand side is system. Right hand side is input.
So how do means
Left hand side system in a differential equation. Left hand side always system. Right hand side is input.
Okay.
So system having time constant.
Yes, sir. Yes.
Yes or no?
Yes, sir. Yes, sir. Means that step I didn't got how left side is system. Okay, sir. Now I got it. So
Left side always system. Right side always input in the differential equation.
Okay. Means x is the input. Means
X is the input. Y is the output. Y is the system. So system only gives the differential terms, na?
Yes, sir. Sir, and I'm having one more doubt. Means I am getting confused in all the K's. Means there 1K we are finding by product of poles or product of zeros. So I'm getting confused in K's. So there are many
K's
K's.
means?
So K. So like one K is DC gain. One is a product of pole by product of zero. All these are same.
Not same. Whenever they ask that steady state gain, DC gain, 1 minute. Right. Now tell, what is your doubt?
So my doubt is you said one formula.
System gain means numerator constant by denominator constant. That's all.
Yes, sir, that I understood.
DC
System
gain means put it G, K, S equal to 0. That's all. Now, what is the doubt?
And sir, one formula K is equal to product of poles by product of zeros. There, which K we are talking about?
That is what this numerator term gain, open loop gain K.
Oh, that is also system gain now.
System gain only.
Okay, okay, sir. Got it. And so marginal K is different now.
K marginal is different.
Okay. So by graph we are finding out K, there we are finding system gain by product of poles.
Yes, system gain only. I told now magnitude condition, what it gives.
Yes, sir.
Purpose, system gain
yes,
K.
Okay. Yes, sir. Yes. Okay, sir. Thank you.
Abdul completed na?
సార్ ఇంకోటి ఇందాక ఒక అబ్బాయి అది 20 అని ఎలా తీసుకుంటారు సార్? 20 అని పోల్ పోల్స్ ప్లస్ ఇందాక అతను అడిగాడు కదా మొహమ్మద్ అని -20 అని +20 అని పోల్స్ కి చెప్తున్నారు కదా, అది అర్థం కాదు.
I didn't get what you are asking. -20 and +20 and what?
పోల్స్ కి -20 అని తీసుకుంటాం, జీరోస్ కి +20 అని తీసుకుంటాం కదా. బోర్డర్ ప్లాట్ అయితే
That will come in the border plots, man.
ఓకే.